After dealing with simple function transformations, it's good to go into a general perspective and look at transformations of any type of function that you get. This is the general summary of everything related to transformation of functions. So do pause the video, write it down. I'm going to explain each one and then go through a simple example. So if you have, we have three main types of transformations: a reflection, a dilation, so either stretching or compressing, and a translation. And the dilation and translation and reflection, all three, could either happen on the x-axis or the y-axis, i.e. either a vertical or horizontal. And it matters, if you notice, usually the ones related to a change with a vertical or something related to looking at the y-coordinate, usually there's something happening at the outside of f of x. And if it's something related to within the value of the function, so it will affect the x value, you'll notice it happening inside the f of x. So that's something to note. For each one, I'm going to give tips on how to do them. It might be quite worded right now, so maybe it's helpful to skip this part, watch the example, and then come back to this part as I explain a bit more. So if I need a reflection on the x-axis, so I'm completely bringing my graph down to from the x-axis, as if the x-axis is the line of symmetry or the mirror itself, then I'm going to just put a negative outside my function, my f of x. So every output is going to be negated. So that's why the reflection is going to be to the negative y-axis value, or switching to the positive y-axis value. And so the x-axis behaves as the mirror. But if I want a reflection within as across the y-axis, then I'm going to put the negative inside. Now, what does that mean? Just to be aware, we've done this before in like the basic functions video. If my function is 2x and I'm asking you to put a negative x in there, all I'm saying is change the input to a negative x instead of an x. So it's just going to be a negative x, so I'm going to have a negative 2x. And that's basically what you're doing. You're just changing the input. Instead of it being a positive x, you're going to make it a negative x. And that applies to like all of these internal transformations. Go back to how you substituted in function, inside of function. Basics of functions, you've done this before, but now they have another meaning, which is the transformation. The next part is dilation, so either you stretch or you compress. Now the stretching could be a vertical dilation, and basically the vertical dilation happens with a scale factor of a, absolute value of a, meaning even if your a was a negative 2, your scale factor is going to be 2. We're going to keep on multiplying by 2, not negative 2, because the negative does the reflection already. So we know what the negative does. Now, it's a stretch if the absolute value of your a is bigger than 1, and it's a compression if it's less than 1. For example, if it's 2 f of x, if it's negative 2 f of x, both of these are stretches because the absolute value of both of them is more than 1. But if it's a negative 1 over 2 or a 1 over 2 f of x, then both of these are between 0 and 1. The absolute value is between 0 and 1. I know negative 1 over 2 is less than 0, but the absolute value of negative 1 over 2 is between 0 and 1. Therefore, it's a compression. I'll show you what that would look like. If this is my function, then the stretch is going to be this, and the compression is going to be this. So you flatten it out. And what happens is basically the y distance. Okay, so this is really important. So what we've changed is the y distance, the distance from the y-axis, the y-coordinate distance. And the way you measure it is from the x-axis. So you're going to measure from the bottom, from the x-axis to here. This will give you the y distance. So you measure from the bottom to the top. The opposite is a horizontal Tarnisation, and what it is, it's a value inside, and that multiplies with your x. So you have a scale factor of 1 over the q value. So if it was f of 2x, what you're going to do is your scale factor is going to be 1 over 2. Even if it was f of negative 2x, your scale factor is going to be positive 1 over 2. So again, you take the absolute value because we know what the negative does. It's just a reflection. And now if it's a stretch or a compression, it's actually the opposite. So it's quite tricky. I would recommend you spend a bit more time on remembering these facts about transformation. It's a stretch if it's between 0 to 1, and you can test that out with values. If you're dividing by a number smaller than 1, between 0 and 1, you're actually increasing. And it's a compression if it's bigger than 1. So what does that look like? If I have my graph like this, for example, a quadratic, the stretch is going to be that it's going to, let's do the compression first. The compression is it's going to just squeeze more in, and the distance from the x distance is going to decrease. So you're going to have something like this. So it's going to compress. And then the stretch is going to increase. So you're going to have something like this. So the idea, it's quite similar to the vertical dilation. Maybe a quadratic is not the best example, but you're going to see how differently it's going to behave with different functions. But the main thing is that we're looking at the x distance, meaning that you're going to measure, if this is my coordinate, you're going to measure the x distance here, this distance. And you're going to manipulate this distance. And in order to measure the x distance, you need to measure it from the y-axis. Again, these will all be clear once we actually start with the examples. The easiest of them all is for the translation. The vertical translation, you're just going to take your output and you're going to add a vertical translation. If it's positive, then it's upwards. And if it's negative, then it's downwards, and you're going to move it by the absolute value. So if it's a -2, you're bringing it down by 2. And if it's a +2, you're bringing it up by a +2. The horizontal translation, you just need to be careful about the value. The horizontal translation is written as x minus h. And the idea is that if your h was positive, then you're moving it to the right. And if your h was negative, then it's going to look like, for example, if my h is -3, then it's moving to the left by 3 units. But if you're going to look at it, it's going to be -3. And that's going to be x plus 3. So it might be deceiving. It might look like, oh, a +3, so I'm moving it to the right. Actually, it's a -3. Your h is a -3, so just be careful about that. So again, f of x plus 3 and f of x minus 3. This 3 is actually a positive h, so it will move to the right. And this is actually a -3, and it's going to move to the left. So it's only the horizontal translation you have to be careful about. So in another video, I'm going to go through examples, either as a written example with sin x, or graphs on how to deal with the graphs as well. So just make sure you watch those videos as continuation.